Okay, we'll talk about exponential growth first. Growth occurs when the rate adds to the initial amount. So we get this value right here. We get, instead of -1, we get plus, or rather, instead of minus r, we get plus r. So the rate, r is the rate. And let's say it's growing by 3/10, right? Then that would be a rate of 0.3. Let's say it's growing by 30%. Well, a percentage is actually 30 over 100. So that's 0.3. So you would insert that into the equation like this: 1 plus 0.3. That is a growth rate of 30%. And if it was growing at 30% every year, then you would put in the time. The time would be years, and let's say you wanted to know if it's growing 30% a year, what's the amount after 2 years if the initial value is, say, 200. And the y would be the output of the function, right? So y is just that's the output of the function at the point in time you're speaking of. So let's take an example up and let's see what sense we can make out of it. So it says the number of users in millions that belong to a social media network site can be represented by y equals 1.5 times 1.4 to the t, where t is the number of years after 2013. So it says interpret the parameters and make a prediction. So here's what I want to make sure you're understanding. The initial value here is that there are 1.5 million users initially. There are 1.5 million users initially. And the rate of growth, what would you say the rate of growth is? It's 40%. Where did I get 40% from? Well, 1 plus the rate expressed as a decimal, and the decimal is 0.4. So that's actually just 40 over 100. So in other words, the rate is 40%. When I put that together with 1, I get 1 plus 0.4. That is 1.4. Okay? And then the number of years, that's t. So let's say that we wanted to find out how many users there would be 2 years later. Let's say that. So y equals, so let me actually write f of 2. That would be 1.5 million users times 1 plus a 40% rate increase after 2 years. 2 years goes up there. So 1.4, let's do this in the calculator. Let me do it on your calculator so you can see it. 1.4 squared, that would look like this. Let me grab my calculator. 1.4 to the second power. That's 1.96. And then all we have to do from here is just multiply by the a value. And we said the a value was 1.5. So we get 2.94 million users in 2 years. So this would be 2.94 million users in the second year. Okay, and let me introduce you also to one very special type of growth, which is growth that is done continuously. So if instead of just growing, say, at a yearly rate, we grow at the fastest, we grow at the rate of the smallest unit of time. So like not just continuously, not just growing every day, and not just growing every minute, but growing every millionth of a second and approaching that limit. What you'll get is the number, you get this special number, Napier's constant, 2.71828. Or just think of it as 2.71. All right? So this constant is special. It's a transcendent number in the sense that it is not the expression of the ratio of anything. It's an irrational number. It goes on forever like pi. And so let's look at this example, and then we'll try to make some sense out of this new equation you've got in front of you. Maria's parents invested $14,000. That's your initial investment, $14,000. That goes in front. That's the A value. All right? So 14,000 goes out front. E goes right here. Nothing changes with E. The rate is expressed as a decimal. So the rate would be 0.042. If you're wondering where I got that number, it's just 4.2 divided by 100. That's how I convert a percent into a decimal. So I've got the decimal written up here, and then I'm just going to multiply by the number of years. They're saying 10 years. So let's put that up here. So in my calculator on here, what I'll do is if I take the rate 0.042 and I multiply that by 10 years, I've got 0.42. And then I'm going to take the natural number, e, and I'm going to raise it to that power, second answer. And that is 1.5. So then I have 1.5 times 14,000. So I'm going to do second answer times 14,000. Oops. And I get $21,307. So this is $21,307. All right. Okay, onward. So exponential decay. All that changes is we change this sign to a negative sign. The a value is still the initial value. This is still the output of the function, whatever we get for y. R is still the rate. But this number is going to be less than 1. It's going to be a decimal, and we're going to subtract it from 1 so that this whole thing right here is going to be smaller than 1. That's how you can tell that it's decay. T is still time. All right, so let's take an example up and make some sense of it. Right here it says the percentage of the percentage of area in the United States not covered by cell phone service provider can be represented by y equals 0.15 times 0.5 to the t, where t is the number of years after 2012. Interpret the parameters of the equation. So in other words, the number of years, that's t, and the percentage of the area, the initial percentage is right here. So 15% is what is not covered. Okay? That is not covered. That's the initial percent. And this is decaying over time. We're getting more and more coverage, which means less and less percentage is not covered. And so let's figure out what would be the coverage 2 years after 2012. So let's do f of 2. That would be 0.15, 15%. And then it would be 1 minus 45%. So 1 minus, or I should say, 1 minus 55. Okay? And see if you can understand what I'm saying here. 0.55. So the rate of the coverage increase, the rate that coverage is increasing is by 55%. And so I'm actually going to take that away from 1 so that I get a new value for the amount of area not covered. So let's say we're going to 2 years. I get 1 minus 0.55. That's the 0.45, right? That's in the equation. If we raise that to the second power, let's do that here. 0.45 raised to the second power. That's 0.2025. And then we're going to multiply that by the initial value, which was 15%. So we're going to multiply that by 0.15. And so we get about 3%. So let me show you this value. So it's 0.3, or I should say 0.03. If I express that as a percentage, I would multiply by 100. 0.03 multiplied by 100, that gives me this percent, 3%. So about 3% in 2 years would not be covered. It started at 15%. There's a 55% increase every year. After 2 years, you're only going to have 3% that's uncovered.